Hey guys, Mr. Black here. I wanted to go ahead and go over some of the review practice for this coming test. So let's go ahead and get started. So these are some of the topics that are going to be covered on the test. So we've got scientific method, accuracy and precision, speed/velocity, acceleration, kinematic equations, and then the different types of graphs. Position time graphs, velocity time graphs, and acceleration time graphs. So today what we're going to mostly be talking about is these three that have been highlighted here: speed and velocity, acceleration, and kinematic equations. So let's get started. So right here I've got a problem, speed and velocity problem. So we've got Layla jogs with an average velocity of 2.4 meters per second to the east. What is her displacement after 4.6 seconds? So what we need to do here is we need to figure out which equation we're going to use, or figure out what our givens are first, rather. So in the equation we're given that the average acceleration is 2.4 meters per second to the east, and then we're also given the time. So we have time and we have average acceleration. It's asking for her displacement. So what we'll do is we'll use the equation velocity equals displacement over time, and we're just going to plug it in. So the velocity is 2.4 meters per second. We got it from right there in the question, is equal to the displacement, which we don't know, divided by 46 seconds. Okay, so we'll plug that in, then we'll do some quick algebra. So in order to get displacement by itself, we're going to multiply 46 seconds by both sides. That's going to cancel out on this side, and then 46 times 2.4 is going to give us an answer of 110.4 meters is the displacement, is equal to displacement right here. Alright, so let's look at the next one. This next one is going to be an acceleration problem. So while traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the automobile's acceleration? Remember that negative value indicates a slowing down or a deceleration. Okay, so in this problem, our givens are going to be the initial velocity is 24 meters per second. The final velocity is 15 meters per second, right? Because we have a driver that slows down from initially 24 to 15. And then it also gives us the time, 12 seconds. It's asking us to find the acceleration. So we're going to use our equation for acceleration, which is final velocity minus initial velocity divided by time. So we're going to go ahead and plug those in. Final velocity is 15. Initial velocity is 24. Divide that by 12 seconds, and that's going to give us our answer, which is acceleration is equal to negative 0.75 meters per second squared. Right? So that means that it's going to be slowing down 0.75 meters every second. All right, last one. Last topic. This one is going to be talking about the kinematic equations. So we're going to have to use the kinematic equations to solve this out. So when we're looking at this question, we need to make sure that we are looking at the givens first. So in this problem, we are given that the cheetah was running 18 meters per second. Is that final or initial velocity? Well, if he was running at 18 meters per second and then accelerated and so got faster for 5 seconds, so this is probably going to be our initial velocity, right? Because it accelerated, and then its final velocity, we'll find out later. We can also see that the question asks for the final velocity. So we've got initial velocity is 18 meters per second. It also gives us, it says it accelerates at a rate of 1 meters per second squared. So we've got the acceleration is 1. And then it gives us the time, 5 seconds, right? So we've got time is equal to 5 seconds. So now that we have all of our givens, we need to figure out what the unknown is. We're looking for final velocity. It tells us, it asks us what is the final velocity. So that's what we're looking for. So now that we have the givens and we have the unknown, we need to come over here and look at all of these equations. And we need to figure out which one of these equations has everything that we are given and what we're looking for. So I'd like to go in order. So we look from the first one. Do we have final velocity? Yep, we're looking for it. Do we have initial velocity? Yes, it's given. Do we have acceleration? Sure do. Do we have time? Absolutely. So now we know that we're going to use this first equation because we have everything we need in order to solve for velocity, or final velocity. So we've got the equation. Final velocity is equal to initial velocity plus acceleration times time. So we're going to go ahead and substitute all that stuff, the good stuff in. So we'll substitute initial velocity right there. We'll substitute in acceleration and time. We'll plug that into our calculator, or we can just do some simple math. 5 times 1 is 5. Plus 18 is going to give us our answer, which is 23 meters per second is the final velocity. So that is how you work out these types of problems. Make sure you come to your office hours if you have any questions. This test is a little bit more challenging than the last one, so please come to office hours if you need some extra support. Thanks, guys. Mr. Black out.